In this video, I'd like to talk about the math question of the day for Friday, June 9th, 2023. And with this example problem, we need to divide these two complex numbers. And the division of complex numbers is typically taught in a pre-calculus class, though you may also see this in a more advanced Algebra 2 class. So at this point, go ahead and pause the video, see if you can work through this on your own. And when you're ready, unpause the video and we can go through this together. Now, assuming that you have attempted the problem, let's start working through it. And the general idea with dividing complex numbers is that we want to multiply the numerator and denominator by what's known as the complex conjugate of this denominator. And essentially, we just don't want to have imaginary terms in our denominator. And with this denominator, if we multiply it by its conjugate, the denominator will become a real number. And let's say, for example, we have the complex number a plus bi. If we look at what's known as the conjugate of this number, this is just, if we call this z, the conjugate is usually written as z with a bar above it. This would just be a minus bi. Essentially, whatever sign the imaginary term has, you just make it the opposite sign. And if we were to multiply these together, a plus bi multiplied by a minus bi, we have a difference of squares here. And the middle terms with the imaginary components will cancel out. We get a squared minus b squared times by I squared. But I squared is just -1. Since we know I is the square root of -1, I squared would cancel out the square root and we get -1. So this becomes a squared plus b squared. So this is the formula if you multiply conjugates together. Notice that we no longer have imaginary parts here. So that's the entire purpose. We multiply top and bottom by the conjugate of this denominator so that we end up with a new expression where we don't have I in our denominator. So let's start by just rewriting this. Minus 14 plus 22i in our numerator and minus 2 minus 4i in our denominator. And we will now multiply by the conjugate here. So we multiply top and bottom by minus 2 plus 4i. We just make the sign on the imaginary part the opposite. But we have to do that in the numerator and denominator, so that really we're just multiplying by 1, since something divided by itself is always 1. And that way we don't change the number. So we carry out the multiplication now. In the numerator, it's a little bit messier, but we have minus 14 multiplied by minus 2, which is 28. Then we have minus 14 multiplied by 4i, which would be minus 56i. 22i multiplied by -2, which would be minus 44i. Then 22i multiplied by 4i would be 88i squared. But since we have I squared multiplied by 88, that would be -88. So we're really just subtracting 88 here. Anytime we have I times I or I squared, that is really just -1. Now in our denominator, we multiply this difference of two squares, and we know the formula. You end up with a squared plus b squared. Or we could just multiply it out by hand just to prove that we do lose those middle terms. So we have minus 2 times -2, that is 4. Then we have minus 2 times by 4i, which is minus 8i. Then we have minus 4i minus 2 multiplied together, which is plus 8i. Minus 8i plus 8i, that's just 0, so those middle terms go away. And we have minus 4i multiplied by positive 4i, which would be minus 16i squared. But we know that I squared is -1, so in our denominator, we really just get 4 plus 16. And at this point, we can simplify everything. In our numerator, if we combine like terms, we have 28 minus 88. Let's take away 8 first, so that it's 20 minus 80, which is -60. Then we have minus 56i minus 44i. And minus 56 minus 44 would be minus 100i. And in our denominator, we just have 20. So we can divide each of these terms now by 20. Minus 60 over 20, that is negative 3. And minus 100i over 20 would be minus 5i. So when we divide these two complex numbers, we just end up with minus 3 minus 5i. And you could check this with a calculator if you know how to use complex number arithmetic on your calculator. Or we can check this by just multiplying our answer by this denominator, minus 2 minus 4i, and we should get back this numerator here.